Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 92nd question of the problem solving series and the second question of the topic trees. Trees is a very important topic in our problem solving series and a lot of companies are asked majorly questions from trees. The difficulty level for this question is easy and then this question has been asked in Google, Meta, LinkedIn, Amazon, Apple, Adobe, Uber and many other companies. Height of a binary tree. We also call it maximum depth of a binary tree, right? That means when we are given a binary tree and we have to find the maximum height of the binary tree. By height, what do we mean? That from root to the which node it takes the maximum distance to travel when every distance is 1 unit, right? From root left to right, it takes 1 unit. So if we consider this is 1 unit, we are taking 1 unit of time and then this is 2 unit of time, right? So height is actually the number of nodes that we are touching, right? So in this binary tree, you can see that from here to here there are 2 nodes, right? In this path, left path, so 3, 9. So this path, if you check, root left and it's right, left correct. So this is the height, right? So maximum height is 1, 2, 3. If we choose this path, so it would be 1, 2, 3. If there was one more node here, 12, then it would have been 1, 2, 3, 4, right? So here in this example, the answer would be 3. If there was one more node here, 27, anything, then 1, 2, 3, 4. For this example, the answer would have been 4 because that is the maximum depth and we are touching these nodes, okay, traversing this node. So it is actually this. If you see the path, so 1, 2, 3. So there are 3 paths plus 1, right? So that is our answer. That is the height of the binary tree. Now how do we solve this question? We are given this function, we are given this root, right? Left, right, you know this. Now what should we do? What is the base case option? What if there was only one node, say 3? Then what we would have done? We would have returned, what would be its height? Its height would be 1. So like you saw in the in-order traversal, we used to traverse to the left part because left subtree, everything is same, right? This is a hierarchical data structure. Trees is a binary tree is a hierarchical data structure, binary hierarchical structure. So everything is same, right? So since it doesn't have any left part, if we go to the left, we see it is null. It doesn't have anything, right? There is no value, so null. We go to the right part, we see we don't have anything, right? So what do we return? We return 1, right? So when the left is 0, right is 0, we return 1. But say if the left had a value, left had say 7 and 8. So what is its height? 2. And what is the height of right? 0. What is the answer? So the height of left, whatever it was there, 2, and this one 3, right? So 1 plus height of left it was there because right did not have. But if there was one element here 7, like for example here, okay, let's look at this example only. It has one element here, one height, but it has, what is the height here, right? If we include this part also, 27. So 1, 2, 3. So this right subtree's height is 3 and this left subtree height is 1. So which height should we choose? Right one, right? Because it has 3. So this 3 plus this actual element. So that is our answer. So what is our answer? We check the left height, we check the right height and we return 1 plus max of left and right. Correct? Left height and right height. So that is what we are going to do recursively because we have to do, right? So for whatever we do for this, same thing has to be done for this. And whatever I will accumulate, it will return back this one and this will return back this one, right? You know recursion. So what we do, so if root equal to null, right? So if there was no element or if this doesn't have anything, right? So it should return 0, right? So if root is, if there is no, if root nothing is given, so if root is equal to 0, we return 0, right? Then we take a left, say we define a left. int of L, okay, and we call max depth and we pass root left. Go and find the left root height, okay, fine. Then we go, okay, now I have asked this to find the left root height, it will find and give me. I also want right root heights, okay, every time. So because left and right height is needed, so it will go and ask him to find the left height, then ask him to find right height, and then what it will do, it would say once it get the height, it would return, okay, 1 plus max of left height and right height, whatever the answer is there, that would be returned. So this much will give us the answer, because this thing once it goes to the left, it would find its height also. Let's try run this code, okay. So okay, including this, okay, so this is our answer now. Say 3 went here, 3 is not null, okay, so it won't return 0. So we'll find the root left height. So now 9, we are at 9. Now 9 goes here and 9 is not null. So max depth of 9, it would ask to find the left height. So now left height, it goes here, it would return 0. It doesn't have left. Once it doesn't have left, so when it doesn't have left, it would return 0 to this. Left would return 0. So they ask, okay, find right height. So it doesn't have right because this is null. So this will return 0, so return 0 would go here. So for this left and 0, right, both are 0, right? So it would say, okay, what would be my height? So 1 plus max of LR. So max of 0, 0 plus 1. Because this is the node itself. So this will return 1 here. Similarly, this would go here. Now for this one, root left was called. Now root right would be called. So it would find its height. And its height would be 1, 2. So this will return 1 to itself because it doesn't have any node. It doesn't have anything node, it will return 1 here. And this one will return, okay, 1 has come here from left, right it doesn't have anything, right is 0. So 1 plus max of left, right is left, right? So 1. So 1 plus 1, 2. So it will have 2. So this will return 2 here, this will return 1 here. Okay, so now L is 2, R is 1. So what would be the max height of this? What would this return? 1 plus max of 2 and 1. What is 2? So 1 plus 2, 3. So this 20 will get 2 here and this will return 3 here. Now for this root, the left value is 1 and the right R value is 3. So what would this return? The main function where it started, 1 plus max of 3, 1. So 1 plus 3, so 4. So this will return 4, which is the answer. In this way it will work. This is one of the useful function. You need to use it in other questions that we solve for trees, because we might need the depth of the binary tree. Okay, so you need to have this in your mind. Okay, the link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 92nd question, maximum depth of binary tree in the LeetCode platform. You can see these companies have asked these questions. Okay, so we have discussed this example already, exactly this example. So let's look at the code. The code is simple as the most simplest code. Okay, we have already discussed this, so we will just directly submit this. So it has been accepted, and it is, have you ever understood these 2 basic questions of trees? And see you also in the next videos, where I'll be explaining the 93rd question of the problem solving series and the 3rd question of the topic tree. Jai Jinendra.